In the movie Interstellar, why is the black hole different from the real image captured in 2019?
They're not quite the same. I've had a number of people email me and say, gee, you really got it right. We didn't get it right at all. There's no crossbar here. And it's brighter on one side. We're not brighter on one side there. So what's going on? Well, here is one way to understand what's going on. So the camera for the movie Interstellar is near the plane of the disk. And so that's what it looks like in Interstellar. But we're going to move the camera up to the North Pole and see what happens. It's pretty obvious. You lose the crossbar. And then you blur things out because the radio astronomers don't have very good angular resolution. And so you get this.
Hey, so I'm sure you've seen this video, and it's been sent to me about a dozen times, and I decided to make my own so I can explain how it works to you guys. Now, the design itself isn't exactly something I'm proud of. All I did was take some bar stock just to make this as an example. Really, the only important factor is that you have two balancing points. So in my case, I just made two little legs with sharp points on each end. After tack welding all the little parts together, I then made a balancing bar with counterweights. And now we have the little guy balancing, and he'll tip forward and back no problem. This is because as he tips forward and back, he's only on one axis. Right here in the middle is the center of gravity, and his legs are on either side. But when I disrupt the forward and back motion and add a side to side motion, and now it looks like he's walking because his legs are trying to equalize and find the center of balance. What's really kind of interesting is if you spread his legs apart, now he's actually more stable, which makes him wobble at a faster speed. And then if you bring the legs together, they're closer to the CG, so this makes his walk a little bit slower and more unstable. I've made balancing sculptures for 10 years. I really do understand how they work, but I can't truly predict their motions. It's like they have a life of their own.
When it comes to fire, the most common color is probably orange or red, and this is usually from burning something like wood. What I've always found interesting, though, was how many other colors are possible, and it can really depend on what's burning. For example, if I add a solution of boric acid and methanol and light it on fire, I get a really nice green color. I can also throw some aluminum into an acidic copper solution and get a blue flame. What I think is even cooler, though, is what happens when I burn nitromethane. It actually doesn't burn on its own, and I have to give it a boost with some methanol. Now when I try it, I get a flame that has almost no color. There is a slight hint of yellow, but besides that, it almost looks like it's in black and white. In my opinion, it kind of looks fake, and I think this is better than anything with color.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highway.
Will we just explode? I told you I did? Oh my god. Just 19.
That's great. Thank you.
Great job, guys. Great. Yep.
Tonight, I'll be dating her. Tonight, I'll be dating.
Think I can crush this penny between my fingers? Piece of cake. I don't have superpowers, I just know some chemistry. I started by scratching some pennies to reveal the zinc underneath, and then threw them in hydrochloric acid. The acid dissolves the zinc metal while leaving the copper shell untouched, and before long the pennies actually float up to the top. After neutralizing the acid, I'm left with these cool hollow coins that weigh only a few % of the original. Pretty cool, right?
If you love seeing art and science collide, you're definitely going to want to watch till the end of this video. In case you're new here, this is bismuth. Bismuth is a very dense metal with a very low melting point, and it's actually the main ingredient in Pepto-Bismol. The bismuth molecules have a crystalline structure, which means under the right conditions, they can make beautiful crystals. As you can see inside the pot as I'm pouring this metal, they're generated from slow cooling, and as you can see, I got a beautiful pyramid crystal in the middle of here, but it's going to be a challenge to get out because it's really brittle. There's so many crystals in here, but I have to bust it apart because it's too much material, but boy is it beautiful to look at. The pieces do not disappoint. Look at the stair steps and the swirls and colors. This batch did not disappoint. Time to gather all the pieces and melt them down again. Thanks for watching. Follow for more.
A lot of you are asking, what are these and are they alive? This is a diaphanized mouse. Diaphanization is a chemical process developed by scientists to better understand the anatomy and biology of animals. First, they go through a cartilage stain, which is all the blue that you're seeing. That's all their cartilage. Then they go through a trypsin bath, which replaces all of their tissue with collagen to make it appear translucent. Then to the bone stain, which is all the purple that you're seeing. This process can take months to complete. Now this practice is used as an art form, kind of like taxidermy. And no, they're not alive.